dun, 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 dun. We're in a statistics class. Let's start with the very first definition. What is a statistic? Yeah, that right there, that's the response I usually get. Okay, so thanks for the blank stares. You took a class not having any idea what this class is really about.
Okay, I have no idea what I'm doing.
Dreadful technique! You've confused rays with beams.
If we want to talk about what a statistic is, then it helps to talk about the opposite, which is parameters. These come from a population, while the statistics come out of a sample. Let's try an example. Let's say I want to know in the whole US, on average, how long can people hold their breath underwater? And let's say that the true parameter was 45 seconds, and that's the average for everybody in the US. But how would you know that? Well, you could survey everybody in the US. Excuse me, sir, this is for science, and dunk them in the water. How long can you hold your breath? That's going to be really hard to do. Realistically, if you wanted to try to figure this out, what would you do? You would take a sample, which is a small subgroup of the total, and from that sample, you would get an average, let's say in this case, 41, and it didn't line up on the parameter exactly. Why not? There's fluctuation in who you pick. Maybe the people who agreed to be part of the study weren't people who could hold their breath as long as normal, and that's always going to happen when you're picking a random sample. This group isn't going to be a perfect representation of the whole, but we are hoping it's going to be close. How close could you get? Imagine if you sampled the whole population. Well, now it gets fuzzy. Are we talking about the sample or the population? You're getting a statistic from the sample, but in that case, it would match the population. That's what we call a census, which kind of fits somewhere here in the middle because I'm not real sure where it qualifies. Sometimes a census isn't really realistic. Surveying the entire US, as soon as you did it, somebody would be born and your sample would be off because that baby can hold its breath. Babies actually can hold their breath. I'm not being weird. If you dunk them underwater, please don't try it, even for science. Populations are the group that we want to survey, and the parameter is what we really want to know. But our sample is a flawed subgroup. Flawed because randomness says you're not going to get a perfect representation of the whole population. So that statistic is what we have. We hope it's close to the parameter, but unless you're doing a census, it's probably going to have some flaws. Although if you really want to annoy a statistician, talk about your sports statistics. Are those really statistics? You have every single yard thrown by that football player. That's not actually a statistic, that's a parameter, but nobody wants to call them sports parameters. So the parameter is the truth. There's no error. It is the facts with no mistakes. Unfortunately, unless you're actually able to do a real census, which even the US Census has flaws, it's going to be an unknown value. So the statistic has error, and this class we're going to talk about how much error for the purpose of saying how close is that to the truth that we wanted to know based on rules, mathematical rules of probability, and then we can use that to make decisions. For example, we have a swimming class to teach people to hold their breath longer.
All right, Leroy, who's the one and only Malcolm?
How long could they be for on average? How long after the class on average? Can we say this class is helping people hold their breath underwater? Those sorts of things. This class is all about how do we make a decision when we need the truth, but what we actually have is data with error. We have statistics.